Assalamu alaikum warahmatullahi wabarakatuh. In the second part in this video we will create a vertical vessel with a hemispherical head with negative straight flange, but by using the features of SEG software instead of using the Access database file which exported from PDL software. Now let's start creating our project. From here, vertical vessel, define the location, select a vertical pressure vessel module and click on finish. Now SEG software will create the project files. From here let's select the equipment, and from the head button let's create a bottom head, and from the bottom head let's select from this list a hemispherical head with negative straight flange, and from here let's define the inside diameter of this head, define the thickness of this head, the thickness of the shell, the minimum thickness after forming for the head, and make this head as a flipped head. Here an option for making this head as a single part, or an assembly from two pieces, or assembly from different pieces like that from segments, but in our case let's make it as a one piece and click on save. Now let's create shell course CAN1, and from here let's select CAN1 and select shell to hemispherical head according to division 2. And from here let's define the inside diameter, define the shell thickness, define the longitudinal welding line orientation and the shell length, and from here you can make it from more than one piece, and let's define the head thickness to be 20 millimeters, and let's select flip option to flip the chamfer edge. Now let's click on save, and from the assembly let's click on start assembly. Here that's the bottom head as a hemispherical head with negative straight flange, and here we have the shell with chamfered edge. Here if we let's create a simple drawing from here, and let's make it 1:100 for example, and if we make a center line here, you can figure that the center line is located on this chamfer edge here of this shell. And if we measure the inside diameter of the shell, and here the inside diameter of the head, if we add that value, you can figure that that's the inside diameter of the head, which will give you this chamfer. And by that way you can create a professional head with negative straight flange, and instead of using head with straight flange equal 0. Okay, now let's complete the vessel. Let's add CAN2, and from CAN2 let's select shell type, define the inside diameter and the thickness, the longitudinal welding line orientation and the length of this shell course, and click on save. Let's add CAN3. From here let's add CAN3, and let's make it looks like CAN1, but here we will change the thickness to be 32 and the length to be 2013, and let's make it flipped from here. Remove the flip option, and let's add the top head. From here let's add top head, and let's make it looks like the bottom head, but we will change the shell thickness and remove the flip option and click on save. Now when we try to create the other parts, here we have the second shell, the third shell with chamfer end to the hemispherical head at the top. Let's take a section view and here you can figure that that's the connection at the ends. That's the professional way. Now let's add some attachments like skirt and a bottom nozzle. So from here let's add a skirt. So skirt, and from the skirt let's define the inside diameter, the thickness, longitudinal building line orientation, the length of the course, the base ring inside diameter, base ring outer diameter, base ring thickness, bolt circle diameter, and the hole diameter, number of holes. Here let's add the rib spacing, the bottom width, height of the rib, bottom width, the thickness of the rib, and we have a top plate, so the top plate width and radial length, the top hole diameter and the top plate thickness, and we have another skirt thickness based on the sketch on the right hand side. So let's define the length of this one. Let's add a bottom nozzle, which is let's add in 3. So from here let's make it as a nozzle from pipe, select the schedule, the offset from the center line. Let's keep the projection as it is right now, and let's add an elbow. So in 3 elbow. From here select long radius 90 degree, define the size, schedule, and click on yes. Let's come back to the nozzle to define the projection. From the calculator here, that's the projection, and let's calculate the actual nozzle projection according to the image here and click on save. Now let's add another pipe in 3 pipe, keep the type as it pipe and select the size to be 2 inches, schedule, and 1500. Let's add flange in 3 flange and select according to azimuth B16.5, rating, size, and schedule. And now let's select the option of preview of the child and click on the assembly. Here we have the value of the bolt circuit diameter is not correct, so let's wait the finishing of that. So here, after the finishing of the assembly, we can save this node. Okay, and let's add a connection point to add a skirt event and skirt access. So connection point as a shell. So from here let's move it before CAN 1. So this connection point, we will select connection point for nozzle as a shell, so it's not a real element. Let's define the inside diameter, the same inside diameter of the skirt and the same skirt thickness. And from here let's add a nozzle with internal and external projection, which is skirt opening. And from here let's select the size as 4 inches, scalable standard, and for the location we will make it with a negative value with the same nozzle orientation, the external projection and the internal projection. Here skirt opening, let's add a skirt axis, the same skirt axis. So from here let's select 24 inches and select the scalable to be, let's say, standard, and the location with a negative value, the orientation 190 degrees, the external and internal projection, skirt axis. Let's click on save. Now let's assemble that. Here, according to the modification of the bolt hole diameter or bolt circle diameter, now it's appear on the SMP after the modification. We can add a washer to this anchor chair. After finishing this, we will add anchor chair. We will add a washer. That's the skirt axis, skirt opening, and the skirt axis. Now we have the nozzle opening and the skirt axis on the skirt. Now let's add a washer. Here let's open a drawing, a draft drawing. Here we have this draft drawing. So if we measure the location of this nozzle, the location of this skirt axis. Okay, now let's add a nozzle M1. So from here let's select a forged hub nozzle to be 20 inches, and the scalable, let's make it 40. The location and the orientation, the hub height, hub thickness, and bevel height. And let's click on save, and from here let's add a flange M1 flange as maybe 16.5, rating 20 inches, scalable, and click on save. Let's add a gasket. Rating, size, save. Let's add a blind, M1 blind. Rating, size, and make it flipped. Now let's run this simply. Here we have this forged nozzle. Let's modify the projection. So we can modify the projection from the calculator. So let's make it like this. And let's add a hand grip, M1 grip. Let's make it 2 grips, and let's add a stud bolt, M1 stud, UNC 1, and the length and the nut spacing And if you would like to add a detailed diagram, we can do that. Here the projection of the nozzle will be modified. Here we have this manhole with bolts. By the same way we can complete the other nozzles, and that's the way to create a vertical vessel with hemispherical head with a negative straight flange by using the SEG features and tools. One more thing here for the bill of material. Here SEG calculates the complete bill of material for this equipment in detail, and you can export it to your drawing or you can export it in Excel format. Thank you for your time.